All right, so now we're going to continue on with 3.5. This is example 3, number 3. And what they're going to have you do is write an equation of a parallel line. So it says write an equation of a line that passes through the point negative 1, 1 that is parallel to the line y equals negative 2x minus 3. Well, to do this, you have to have some prior knowledge of writing equations of lines. You guys did that last year in Algebra 1. But so far what we've learned is, well, we need to have, if we want a line to be parallel, well, the slope has to be the same as this slope. So if you recall, the slope for this one is 2, because y equals mx plus b. And if you notice, if you compare this equation right here, the 2 is in the m position. So I know that the slope is 2. So that means that the slope of my line that I'm trying to write an equation for will also be 2. So let's go ahead and plug that in. Let's go ahead and plug the 2 back into this equation over here. So it's going to be y equals 2x plus b. Now we still have some other information. If you look up here, I have an x value and I have a y value. So I can take that information too and I can plug it back in. So I'm going to go ahead and plug that back in to my equation that I had previously. And I know that my x value is negative 1. And if you notice, I don't know what my b value is. So by plugging these in, we can actually find that b value. So negative 2 plus b, add 2 to both sides, add 2 to both sides, and your b value will be 3. So now all you have to do is take that information and plug it back in. So I'm going to take that. So we'll take our b value and go ahead and plug it back into the equation that we had. So y equals, we know the slope has to be 2, x plus 3. So if we were to graph this, if you were to take this and graph this, we would know that it would go through this point. And how do you know? Well, you could check it. You could go ahead and plug those points back in, plug those values right back in, and it should work for both sides. So 1 equals negative 2 plus 3. 1 does equal 1. So I know it will go through that. So this equation right here is parallel to this equation. Well, how do you know? Because of the slopes. The slopes are the same. And if you notice, I took the time to copy and paste the two graphs, or if you were to graph these by hand, if you notice, they are parallel. Okay? Do you notice what needs to be the same is the m value, and then what needs to be different is the b value. So if you look at these, if you just looked at these two equations, from now on you could say, yes, Mr. Deschler, I know that these are parallel because they have the same slope but different y-intercepts. So now I'm going to show you is how to do this, how to write an equation of a perpendicular line. So here's an example number 4, write an equation of a perpendicular line. Write an equation of a line that passes through the point 2, 3 that is perpendicular to the line 2x plus y equals 2. Well, the first thing that we want to do is, if you remember, a linear equation that we like the best is in the form y equals mx plus b. So we're going to use this information, but if you notice, what form do we have in the example? Correct, standard form. So what you want to do is take standard form and we want to go ahead and put it into slope-intercept form. So to do that, what we're going to do is basically just solve for y. So 2x, negative 2x plus 2. So now if you notice, it is in that form y equals mx plus b. So now I know all I'm really concerned with right now is, well, what is the slope? The slope of this is negative 2. Now, I want to find a perpendicular line. So the slope of my new line has to be the opposite reciprocal of negative 2. Well, what's the opposite? Will be positive. What's the reciprocal of 2? 1 over 2. So I'm going to use that information now. So since we put it in slope-intercept form, we have y equals negative 2x plus 2. Now we want to do the same thing with our new equation. So our new equation will be y equals 1/2 x plus b. Same process as before. I'm going to go ahead and take my point and plug it back in. So we know from up top there, right here, our point was 2, 3. So our x value goes right here. Our y value goes right here. Now all we have to do is solve it out, and we get 3 equals 1 plus b. We're going to subtract, and we get b equals 2. So it turns out it is the same y-intercept. That might not always happen all the time. So when we graph this, or when we write the equation, we want to say y equals 1/2 x plus 2. So these two lines right here are perpendicular to each other. And we know that because of the slope, opposite reciprocals or negative reciprocals. Now, if you were to graph these, you could take a look at it. You could graph them. And once you have them graphed, they'll look like they're at a 90-degree angle, but the best way to be certain is you take a protractor and you'd measure that angle, and you would get a 90-degree angle. But just wanted to show you, visually show you what it looks like. So what I'm going to have you guys do now is go ahead and turn to page 158 and numbers 4 and 5. So give that a try. And look back to this video as you're doing it so you have a guideline to go by. And I'm going to show you one more example in this video, but I'm going to stop here. Good luck.